When you run an ANOVA, the results will tell you if there is a difference in means. However, it won't pinpoint which means they're different. Duncan's multiple range test is a post hoc test to measure specific differences between pairs of means. The test has a higher power than the Newman calls. It's more useful than the LSD when larger pairs of means are being compared, especially when those values are in a table. The MRT tends to require larger differences between means compared to the LSD, which guards against type 1 error. The MRT assumes you have already run ANOVA and you've got a significant result. We're going to calculate the MRT for the following output. Step 1 is to rank the treatments from highest to lowest mean. For this set of data, the means in order are 39.3, 20.7, and 11.3. The next step are to compare the highest mean 39.3 with the lowest 11.3. First, we are going to look up the Q value in this table, with 3 treatments and 6 degrees of freedom for the error term. The Q value is 4.34. The next step is to find sigma d squared, that is going to be 2 times the residual mean square divided by number of treatments. And there's our residual mean square for the ANOVA output. That gives us 5.85. And we take the square root of that to get sigma d. And we want to multiply that by the Q value. That gives us 10.5. Next, I want to calculate the actual difference between my two means. So, if I subtract those the highest mean from the lowest mean, I get a difference of 28. And I'm going to use the value I just calculated of 10.5. 28 is greater than 10.5. So we can conclude the highest mean is significantly different from that of the lowest mean.
Created using Powtoon.